jumped in at the last minute. For that reason, this won't be the most polished presentation, but I'm setting that context. All right. There we go. So I changed the title at the last second. Thank you guys for having me here. This is me. That's me. Work for this guy. We work here. Actually, no. Bunch of things have changed. So one thing that's changed is we're digging open source now. We've got a bunch of projects that are released under open source licenses. One of them is the project that I work on, which is bringing Node.js to Windows Azure, but we have a whole bunch of SDKs for Windows Azure that are under Apache 2. If you look over there on the right, though, we're also taking contributions now, which is huge. Darth is turning over in his grave on that one. And we've also recently embraced Git, so you can look over there, Codeplex, which is our website where we have a lot of .NET projects. Another project that I used to work on called ASP.NET Web API and ASP.NET MVC4 have also now been released under open source licenses, and they are also taking contributions. What do you guys think about that? That's actually pretty good. So the Death Star has been destroyed. And we're digging Node. And this is just how we're digging Node. One way we're digging Node is we got involved almost a year ago when we heard a lot of people saying, hey, this Node.js thing's really cool, but guess what? It sucks on Windows, and I have to use Cygwin if I want to be able to run my Node apps. And you know, Cygwin, if you read the byline, if you go to their website, it says something like, you know, get that Linux feeling. And of course, feeling is all you got, because you were getting, you know, a lot of people look at Node and they look at it for scale and perf, and when you're running in Cygwin, you don't get a lot of that. So we did that, and we worked with the core team, and we actually have a Microsoft developer who actually works on the Node core team to make sure that Node actually works really well on Windows, which I also think is pretty cool. And then the next thing that we did is we delivered this Windows Azure SDK for Node. So I joined the effort. At the time when I joined the effort, Node did not work on Windows Azure. So, you know, as soon as we got Node working on Windows, a whole bunch of people were like, well, what have you done for us lately? You've got this cloud over here. Node doesn't work in your cloud. So make it work in your cloud. And so that was where I came in. And in December, we actually shipped our first release of this Windows Azure SDK for Node, which includes two things. It includes a set of command line tools for allowing you to publish to Windows Azure. No, I'm not getting markety here. I'm just setting context what we're going to go into. Yes, I'm getting markety. And we shipped an Azure NPM module, which allows you to use some of the services of Windows Azure, whether you're running in Windows Azure or running on any environment. So I could be running in Heroku. Azure offers a set of services like a table storage service, a document storage service. We'll get into those in a minute. So our team wrote this in Node, and it is published as an NPM module called Azure. And so what I'm going to talk to you guys about for the rest of my session is just some of the experiences we had learning about Node and building that Azure NPM module. And one of the things that was interesting about that Azure module is because it is an HTTP client, it's consuming a set of REST, quote, REST APIs that are exposed over Windows Azure. So we weren't just building any old module, we were building a module that is an HTTP client. And we had a bunch of challenges there because really in that kind of model, your client is just a wrapper and it's wrapping over these existing APIs, and you have to go through a lot of thinking about what's the right way to expose it, etc. And that's what we're going to talk about. But we're also going to just talk about general things we just learned about as a team building an NPM module and publishing it, and we went through all the, you know, JavaScript isms and everything else. So I'm just going to go through that. It's not in a super order. And feel free to ask questions. Oh, I forgot to say, but we will always cherish the good old days. So let's get into the module. So what the module is, it's a client for a set of Windows Azure services. Windows Azure offers two high-level things. One thing Windows Azure offers is the ability to just run your code in the cloud, the Heroku-esque or EC2 type experience. Windows Azure builds up VMs for you, so it's a little bit different than Heroku. It's probably closer to an EC2 model. And then we have these sets of services like table storage, which is a lightweight NoSQL database, blob storage, which is a document storage. We have Service Bus, which is actually pretty cool, which is it lets you do pub sub in the cloud. So you want to like send notifications and send them to many different places, or you want to synchronize servers. It's pretty rich. It has subscriptions, topics, etc. Don't worry about it. I'm not expecting you guys to have to use it today. But I thought I'd show you just a very, very quick demo, just to set the context. It's going to be really quick. So this is an Express application, and it's using our module. What's it doing? It's just listening. It should be working. HTTP localhost 3000. Yeah, it could be 1337. So this is a little blob uploader, very simple application using Express, and I can upload documents, and then I can view those documents by downloading them. But they're not just images. I can do all types of things. This one I kind of like, for you Star Trek fans out there. So this is actually using the table storage. So if we just take a quick look at what the code looks like. So here I'm requiring the Azure module. And then as you drill down, you'll see things like I create a blob service off of that Azure module. And that blob service is going to give me a client that I can then use for actually talking back to Windows Azure to then work with the documents. So if you go down here, you can see things like I can go to the blob client and say, get me the properties. I can list the blobs first. Once I list those blobs, I can grill in and get more information, like getting the properties. You can see there's lots of callbacks all over the place, which is something you're definitely going to see when you're doing something like this, because of the fact that everything is really about just doing communication back and forth with this remote server to get access to the services. Anyway, so that just gives you a context. And we have a bunch of services like this. I'm not going to show them all to you, which is the difference between if this was a Microsoft event. Anyway, so what did we learn? So the first thing we ran into was, just what are the things we should do when we write JavaScript? Now, how many people here actually have worked with Node? Okay, just a few of you. And how many people here have worked with client-side JavaScript? Okay. So I think the big thing to think about when you make that transition from a client-side app to Node is you're moving to a full-blown application. There's a lot of things that come into play that don't as much affect you when you're on the client. And one of them is the scoping thing really can get in the way. So the idea of scoping is if I just declare a variable anywhere in JavaScript, that variable is going to get hoisted up. And it might have weird side effects. So the way you should prevent that is you should always use var and explicitly declare your variables, because then you can have them scoped at a particular level and you don't have to worry about them suddenly getting hoisted up into the global scope. Use semicolons, because if you don't, Douglas Crockford will show up. We do try to use semicolons for consistency. JS Hint was something that we used also. If you don't know about JS Hint, it's a pretty cool tool. There's JS Lint, there's JS Hint. They all have the same idea. I think JS Lint is a bit more opinionated in a Crockford sort of way. But JS Hint, what these tools will do is they'll basically look at your JavaScript code and identify common problems, like if you're not using vars. So we really recommend that you look at using these tools because they'll help you have consistency on the team, and they'll also help you not get yourself into a pit. Because sometimes if you don't follow some of the things that are suggested, like the example I gave with the variable scoping, it really can get you into trouble, and you're sitting there scratching your head. And because the double-edged sword with JavaScript, I mean, it's a dynamic language. It's super rich. You can do whatever you want. But that's the other side of JavaScript is the compiler is not going to help you because guess what? There is no compiler. This is a good reference. It's a great deck that talks about some of the really common practices that people have been using in Node. I'm not going to open it for you now, but you may want to go check it out. CoffeeScript. Don't use it. No. CoffeeScript is really cool, but we actually made a decision early on because a bunch of us actually really liked CoffeeScript. But because of the fact that we were delivering an NPM module, which is a module that other people are going to download, that other people are going to be hopefully submitting pull requests to and things like that, we basically made a conscious decision that we would not publish CoffeeScript code within our module. Now, some people will say, well, I won't publish CoffeeScript. I'll publish the generated code, or I'll put both in there, but I'll have the generated code. I won't do, and Isaac Schluter has spoken out against this. What I won't do is just have loose CoffeeScript files in there and expect that when people pull down that module, they have to have CoffeeScript installed. But we didn't even want to put CoffeeScript files in there because we wanted to reach the maximum number of people. And although there's a lot of excitement around CoffeeScript, there's a ton of people that A, don't like it, B, that just know JavaScript. So in order to, it's about not cutting off your nose to spite your face. If we go with CoffeeScript, then the only people that are really going to be able to help us in terms of giving pull requests and fixes and things like that are people that understand CoffeeScript. So that's our recommendation about it. Now, if you're in a company that is building an application and you're not publishing third-party modules, CoffeeScript may be absolutely fine. If you're in a hybrid situation, I would even say that's fine, but I would still err on the side of taking those third-party modules and not publishing them as CoffeeScript and party on all day long internally with CoffeeScript if that's what your team likes. I hope I didn't upset you with... So creating an HTTP client, as I mentioned, these APIs are consuming other APIs that already exist. And so one of the principles we had was stay really close to the API. Don't try to hide stuff. In some cases, we really didn't like the way that API actually looked, but we still said we should stay close to it. And the reason why you should stay very close to the API is that enables others to come along and build convenience layers on top. And it gives people maximum amount of choice, but it means that you've surfaced the maximum amount of capability that the API actually has to offer. Now, for us, if you were doing it yourself, let's say, and you were coming along and you were saying, hey, I looked at the Azure SDK, I looked at the Azure NPM module, I really don't like it, I want to do my own thing, and I even want to ship that as a separate package, that's absolutely fine. But for us, Microsoft, it's our service. We need to make sure that anything you read about in the API specs, you can easily do. And the other thing that we found was kind of hokey, and this we learned from our .NET implementation of the SDK, was that we actually did try to come along and do an ORME thing, like do these object-oriented kind of approach. And when we did that, it made it very hard for, it worked. It's kind of like this 80-20 thing gets you into trouble. It was really easy for the very basic scenarios, but it started to fall down very quickly when people wanted to do stuff that they read about that the API was supposed to actually support. So my advice, if you're building some type of client API, you can have your own convenience layer, but make that thing be an optional layer. Maybe it's even a separate module. This way it's opt-in if I want to use it or don't want to use it. But as long as I give you all the functionality exposed, then you can actually build on top of that. And don't stifle HTTP. I used to work on a project at Microsoft called WCF, which was all about stifling HTTP. But anyway, and the reason why you don't want to do that is because there's a lot of richness that HTTP has to offer, like caching. There are caching servers out there, and if I can use e-tags, which are a mechanism of where the server returns me a unique identifier that identifies this representation that I have at a point in time, I can actually do conditional requests back to the server with that token. And what will happen is if nothing has changed, the server will just tell me, hey, that's still valid. You can just use what's in your cache. But if I hide that, if I don't allow you to get access to things like the raw HTTP request and response headers, then you have no way of actually taking advantage of those capabilities. And that actually will impact scalability of your application. So try to make sure, and it's really easy actually to do in Node, because in Node, first off, it's all dynamic. It doesn't get in the way. But in Node, like if you use Express, you have the request object, the response object. So at the end of the day, if you can provide a way for somebody to get access to that raw request, they can do whatever they want. You don't have to make the API really, really complicated. You just have to give people that ability to peek down when they want to. Configs. So the gentleman before me just said the exact same thing I would say. So with our APIs, we do have some configuration information. For example, when you use Windows Azure, you have to pass security. You have to pass credential information. You have when you're accessing storage services, you have a key, a unique key, and that key is what allows you to actually get access to, for example, to update data. So one thing I would say is, again, if you're building a module that other people are going to use, don't force your own opinions on there. So, and config was one of them. There's a lot of different ways to do configuration. Some people like to just have a simple config JSON file. Other people, use things like nconf, which is a great library that the Nojitsu guys have that does configuration. Other people like XML, right? There are some. There's a whole SOAP spec that proves it. So the way that you get around that, the gentleman before me was talking about, and I forgot his name, I apologize, environment variables and how you can use end variables for moving between environments. But the other thing that environment variables provide you the ability to do is to say that as long as my library is configurable through these environment variables, that gives people the freedom to use whatever mechanisms they want to, including just hard coding, setting those environment variables to get that information in. And we found that to be very effective. So for example, when you use our Azure NPM module, you'll notice that in several places, we're actually doing like a process.env. Let's see if I can find it. Let's see. Just let me double check this. It's on here. Yeah. So here you can see, like, for example, for proxy information, we're basically looking to see is the all proxy variable set or the HTTP proxy variable set. But we do the same for credentials. We actually allow you to pass in environment variables for things like that that storage key, and we'll pull it just from the environment variable. Now, don't force config in the sense that we do have convenience constructors on our objects that actually allow you to pass those parameters if you want to. And that raises an interesting segue, because one of the things for us coming from a static language, like a lot of us on my team, we had worked like with C# and other languages, there's the concept of overloaded constructors. An overloaded constructor is a way that you can accept different types of parameters. Well, JavaScript doesn't have overloaded constructors per se, but in JavaScript, because it's all dynamic, you can basically design your functions such that the optional parameters are at the end. So this way, you can still give people the flexibility of passing these parameters explicitly if they want to, but if they don't, then the code works absolutely fine, and then it will just fall back to using the environment variables. Async. So that's like the first thing I think you hit into once you start to develop with Node.js and you get over the idea like, hey, I'm going to be writing JavaScript on the server, is this async thing hits you really, really hard. And it hits you much harder often, I think, than what you see when you write JavaScript clients, because you are a server, and Node.js is designed from the get-go that everything is going to be non-blocking. All the APIs are non-blocking. So you hit into manage, how are you going to manage these callbacks? And if you don't, it gets really, really ugly. So the first thing we learned, which many of you probably know, but some of you may not know, is just make sure that whenever you have a callback, that the first parameter is always an error, the error parameter. That parameter can be null, which is perfectly fine. But the idea is that's just a standard pattern in Node. And libraries, some of the async libraries that you use, because there are async libraries that will help you, like a module called async, they actually expect that the callbacks have this first parameter. So they're not going to work properly if you try to use those libraries and you haven't actually followed that pattern. It's an established pattern. And the reason why the pattern is really nice is because it's just consistent. It means that as a developer, every time I'm implementing a callback, I know that the first parameter that I can check is going to be an error or not. And it allows me to do a simple construct, like if error, then throw my error or log or whatever. And what you need to be careful of is when you start to write your callbacks, not turning your callbacks into spaghetti code. Because JavaScript is really flexible, so I can have a function that takes a function, and then that function within it is basically calling another function and another function and another function. I can have all the callbacks just nested where I just have one call, and everything else are just anonymous functions. And there's a couple of problems with doing that. The first problem with doing that is the code is just unmaintainable. It's like a big spaghetti mess. And every time you make a change, you have to worry, did I break the entire thing? The second problem with writing functions in this style, you don't get reuse. If I factor out those functions into separate named functions, it's much easier for me to actually reuse those functions within the context of where they're executing. So I'll show you an example of the factoring. And there's a couple of different ways you can do that factoring. So for example, like within my get service properties here, you notice that I've defined this process response callback as a function. Now inside of it, it actually has a final callback function. That's not spaghetti code there though. Each of these are their own functions. They can be individually tested, etc. But what I'm not doing is just having that get service properties makes a call to, instead of calling process response callback and passing that, you could actually just pass this whole thing in line as a function with functions with functions. It's just horrible. Don't do it. Please don't do it. If you do, I will have to get Darth Vader to do the chokehold. Now, async is a very useful library because what async will do is often when you make this transition towards writing server-side JavaScript, a lot of things that you used to write, which used to be synchronous, you suddenly have to think about, well, how am I going to do that async? How am I going to do that in a non-blocking I/O manner? For example, in the past, I would have queried the database for some record, done some update, and then maybe fired an event. And I would have done all of that in sequence perfectly fine. But in this case, because I'm now async, what I really have to do is make one non-blocking call to get the data that then has a callback. Then in that callback, what I'm going to do is do the update, which is then going to do another callback so that when that update completes, I'm then going to fire my event, for example. That code just changes dramatically in complexity. And if you add in this error handling stuff I was telling you about I have to now add error handling at each phase wherever I have these callbacks, that code gets painful. So there's a great library that makes your life easier, and it's called async. And you can find that it's an NPM module. And what async will allow you to do is simply just stack together a bunch of different named functions that you want it to call, and it will call them for you in sequence. And it will do the right thing. If an error occurs during invocation of any of them, then it will actually capture that error, and it will get rid of you having to write actually a lot of that boilerplate error code. So async is a really useful module and definitely recommend it. There's another module like async called step. Both async and step also can do some interesting things as well, like parallelizing. Now, in Node, of course, you're single-threaded, but basically, like if I have to execute, I want to execute async actions in parallel. Really, it's not true parallelism. Basically, what I'm doing is I'm calling A, and it's going, and it's waiting for its callback to return. And while it's waiting for its callback, it can also do B. So async will actually help you to do a lot of that coordination so that you can do parallel as well as sequential workflows. Another library that we used is a library called Streamline. We used it very carefully. We only used it in one place because Streamline is kind of like CoffeeScript in the sense that it's not JavaScript. It's taking JavaScript and it's compiling it into this intermediate form. But what's nice about Streamline is if you have really heavy async code where it's conditional, where you have to like make a call, and once that call completes, you want to do some conditional checking, and then based on that, maybe make some other calls. Streamline actually makes the syntax quite nice. I'll show you what the syntax looks like. And all of these are modules as well, so it's really easy to get access to this stuff on NPM. So here's an example of the spaghetti code stuff that I was talking about. So you can see here that when this call is running, which is querying the database, well, it's got to do a callback once that data is done to then go do an insert, to then go do a delete. So you can see there's this spaghetti here of all these anonymous callbacks getting shoved together. Now, I can make this cleaner without using Streamline simply by factoring out those functions into named functions like I was just showing you. But this is what it looks like with Streamline. And it uses underscore, as you can see, if you guys are familiar with underscore JS. So this makes that code a lot cleaner because it's basically going to do the query and then it automatically takes care of invoking the next callback for you. Now, what I would say is for this type of thing, I would actually use async because to me, this doesn't actually need Streamline. Although it's illustrating that Streamline is really cool, the way we thought about Streamline on our team, and a lot of folks on the Node.js list think of it the same way, is, you know, it's a tool that needs to be used very carefully. Don't just abuse it. Don't just say that all my async code just goes through Streamline, because again, you get into this thing of all this generated code, and it's trying to optimize above and beyond JavaScript, and there's a bunch of pros and cons of doing that. So for this one, I actually would probably use async because it could do this kind of thing perfectly fine. But if what I had to do was, after I did the query, I needed to then do a conditional check and call this or call that, depending on some business logic, Streamline actually handles that very, very nicely. Because async doesn't. Because async just says, hey, you give me 5 steps, I'll run 5 steps. If one of them fails, I'll back out. For us, obviously, async was a huge thing because we're writing this library that's HTTP library. Okay. Modules. So there's a massive community of modules that are out there. There's 10,000. So when we were going to build our library, at first there was a tendency to say, oh yeah, we'll just write everything. And then we quickly realized that's a stupid idea. A, it's like wasting a lot of our time. B, there's a lot of people that have put a lot of effort in to build things like async, and unless you have something that is significantly different about your requirements, it might be perfectly fine to use it. So one factor that you have to deal with, though, is which modules do I use? There's 10,000 that are out there. So we came up with a pattern that we used, or a set of guidelines, to help to identify when looking at a module, should we take a dependency on it or not? And this is the criteria here. So the first thing we would do is go to the NPM registry and see, is it a module that is highly dependent on? So if you go to npmjs.org, that's really easy to see. You can see most dependent on, right? So async, that tells you right there. Async library is one of the most dependent on. Streamline's not on that list. Sorry, no offense. You can see CoffeeScript really high on there. That means a lot of people are doing CoffeeScript and hopefully being good citizens and not pushing it into their module repos. So that's one way to tell. Another way to tell is to look at watchers on GitHub. because pretty much all the NPM modules that are out there are on GitHub. Ours is on GitHub. And so you can look at number of watchers. Now you need to be careful because it may be that that module is a niche thing. If the module is a niche thing, you just may not find a large number of watchers or a large number of folks dependent on it. On the other hand, if you do see a large number of watchers and a large number of dependencies, that's probably a pretty good sign that it's fairly robust and that people are really finding value using it. So what I would really say is it's a way to kind of drop out fast. If you see that, you can be pretty confident about it. And then the other thing is really look at the documentation and the unit tests. I would put the unit tests higher because the unit tests are ensuring that there's good coverage, that everything that's supposed to work is working. Documentation, like we have, not everybody has the time to actually do the docs, and if you do your tests right, they actually become documentation. But if you don't see any unit tests, seriously, don't go near that module, which will bring my next rant, which we'll get into. Package.json. So if you're publishing a module, you have this package.json, which is a manifest. And so one of the principles that we came up with was, and we're not the only ones who came up with this, is to say that if I'm publishing a module and I get to specify the dependencies, I should make the dependency policy very loose. And that allows for evolvability. And what I mean by that is if a new version of Node comes out or a new version of another module comes out, if your dependencies are loose, then it's very likely that your application will still function. Let me show you what happens when that is not adhered to. So one of the most popular modules that's out there is Express. And Express has a pretty cool scaffolding tool that just gets you going. So if I do Express and I run Express, it scaffolds out an application for me, a starter app. So I can then do npm install and install the dependencies, and it should fail. So why is it failing? It's failing because of the dependency policy that's specified within the package.json. It's not, so I'm saying that I depend on Express 2.4.6, but Express 2.4.6 itself is saying I need a very specific version of Node. I can't work with later versions of Node. But this is actually the latest version of this module, but the scaffolding tool is actually generating to use a different version of Express. It basically just means that nobody has updated the scaffolding tool. That's really what it means. So to get this to work, what I have to do, but it's not always obvious, is I basically have to edit my JSON file. And I have to change this here to be a loose policy. So what I mean by a loose policy is doing something like this. I've now said, hey, anything greater than 2.46 I can work with. So then I can go npm install, and it should work. Yeah, so you can see it works now. So that's the kind of thing that you should really be cognizant of when you're shipping a module, because what that means is potentially, I mean, this is a scaffolding tool. It probably doesn't kill you. But if something like that is done on some critical functionality that somebody depends on, you're basically telling them they cannot upgrade to the latest version of Node unless they either A, fork your module and make modifications, or B, they just stay with the version of Node that they're using. So basically, for applications, though, I would use a very strict policy. If I'm going to deploy an app, if I'm deploying an app, I'm putting it in a repo, or I'm deploying it to production, I want it to have a very strict policy. I don't want it magically changing the next time I deploy it. And there's a very cool tool that some of you may not know about that the NPM package manager includes, which is called shrink wrap. How many people here know about shrink wrap? So shrink wrap will actually lock down your dependencies so they're very specific. So if we look here at the example we were just looking at, I added these ranges in. But if I do npm shrink wrap, why did it get an error? Problems were encountered. Okay, let's see if that's a sudo issue. All right, well, if it was working, npm shrink wrap will actually generate a file called shrinkwrap.json where it will lock down all of the versions to what I have on my machine now. And that means I now have predictability. I know that if I deploy again, it's not going to magically change. I can upgrade and change that if I want to, but it will automatically ensure that unless I make that decision, it's not going to happen for me. All right, so the next thing was, how do we work as a team? We're working in GitHub. We're working in a repo. GitHub has the ability to do things like pull requests, which are often done just for customers. It's a common practice that customers send patches, things like that. They use GitHub pull requests. But for us, what we said is, as a team, we work just like customers. We all go through the pull request process. Every developer is going to fork the repo. They're going to work locally. And then what that means is the team, it's really universal. Whether you work on the team or you're somebody who's sending a patch, you go through the exact same review process. And it means that in terms of commits, everything is all very consistent because everything went through a pull request. Now, sometimes the way we work from a branching perspective is another thing that we really control. So we have main. Main is like our production quality thing that we're ready to say, yeah, just grab it, go with it. Dev is the thing that's in progress. So any feature that is being developed will actually show up in dev. And once we basically have stabilized it, we think it's solid enough, then we'll actually go and pull that and do a pull request to the main branch. But we also sometimes do additional branches, like in some cases, we may have to work on something that is critical, but it's a significant amount of work and we don't want to break the cycle of what devs are doing now. So, but we still want to have that history and be able to check in. So in some cases, we have had places where we'll say, let's create an additional branch that will work from so that it doesn't interfere with the standard development that is going on. How am I on time? What do I have? Okay. That brings to my test grant. So you need to write tests when you're writing code in JavaScript. I was pretty amazed how many startups out there actually are not writing tests, and they put their heads down when you try to talk to them and say, hey, what are you doing with your testing? And I'm amazed for a couple of reasons. One, there's a really rich ecosystem of test frameworks in the Node community, which I think is awesome. I was actually really happy to see that, clap for the Node community, that we have really good test tools. But because it's a dynamic language, unless you're really running your tests, you don't actually know that the code that you have there is actually going to work. It could be that you manually are hitting on it, but as the system gets really complicated and it grows, that's going to be painful. The second point, though, I have there is, don't crap on the community. So if you don't want to write tests internally and your team is fine with that for your application that you're publishing to production, cool, fine, great. I mean, I wouldn't recommend it, but if you're writing a module, don't crap on the community. And what I mean by that is if you've not sufficiently tested the code, they're going to just have to deal with that. They're going to have to deal with your crap. And the other reason I would say don't crap on the community is that tests actually become a form of documentation, which I mentioned before, that allow people to figure out how your API is supposed to work. So you have to choose a test framework. There's a bunch of different test frameworks out there. One thing I would recommend is choose a test framework that has momentum. So we started off, we were using Node Unit. Node Unit is a unit test framework for Node. And we noticed that it was a long time since there had been any kind of commits. And there were other frameworks that were coming online, like Mocha and Vows. Vows is from Nodejitsu, that actually had a lot of really interesting features that we wanted. So we actually dropped Node Unit for that reason. So I would say you want to find one that has momentum. One of the things why we ended up going with Mocha that we liked is that our team has been traditionally more of a TDD style. But Mocha actually also supports acceptance test style, BDD. And you can choose which style that you want. So if that's important to you, you may want to think about that when you're looking at the framework, what styles of testing. And then code coverage, another example of like not crapping on your users. Code coverage just helps you to see, it's not a magical answer that your code coverage is 99%, but it at least tells you that this code is actually getting hit by the test. It's one step to make sure you're doing something to try not to crap on your users. I'm going to actually jump to one last thing because this is actually pretty cool. It's the last thing I want to tell you. In our particular situation, because we're testing these APIs, we had these challenges of the fact that we've got all these different types of requests and things that we need to generate. And we need to see, like, are the right requests getting generated? Are the right responses being received? And so from an integration testing standpoint, we said we really need a way to get in the middle of those HTTP requests and responses. Now, there's a framework out there called knock, and knock will actually allow you to mock your HTTP requests and responses. But in our case, we wanted to actually support cross-platform SDKs, not just Node. So we decided to write a tool in Node, but that tool can actually work for anything, because the way it works is it sets up a proxy on the machine, and it will intercept all HTTP requests, and it has a record mode and a play mode. So in record mode, what it will allow you to do is to make requests against a real server. It will record the request, it will record the response, and it actually writes it to a file. I'm going to show this to you right now. And then I can put it into playback mode, and in playback mode, it will let me know if for some reason the request is not getting sent over properly, or when the response comes back, it's not properly being handled. And this is actually available. If you get our Azure module, this is available in the box. So we haven't ripped it out into its own yet, but it is there under an open source license, and anybody can use it. So if I go into my Node modules folder, and if I do npm test, you'll see that it's running my test runner. Now, one of the things we did is we actually created test lists. You'll notice it has this util test, Azure test, etc. We created a runner, which you can also take, anybody could write it, that starts with a text file. And that text file identifies families of tests, and then you can actually specify run this family, don't run this family, because some of them are long running, for example. I'm only here running the short running ones. But here, this is actually using that record play framework for mocking HTTP. So if you look down here, you can see I have these recordings. And as an example, here's one. So this is actually Windows Azure APIs expect XML today. We're actually looking at also supporting JSON. So you can see how here's a particular request that I'm expecting, or here's other request and response type things. So it does all that recording for me, so then I can just go play that back. And then if I look into the actual service code, like for example, table storage code here, I have this batch utility that sets up my mock server. Let's see where that is right. Here is it. Here it is. So you can see that I have this mock server client, and it has this mode of is mocked, is recording, and I'm setting it up. And what it will basically do is just set up a proxy on the machine so that all the requests will go through that. And in our case, you don't have to only use this for doing node development. So any of you guys that are out there, if you want to take advantage of the mock server, you'll have to learn a little bit about Node to use it, but you can use it for any kind of HTTP request response stuff that you're doing. All right, so that really covers kind of the high level of what I wanted to go over, just talking about our experiences. There's other things I could go into, and certainly some of our experiences were shaped by the fact that we were building this client that really had to do a lot of work over HTTP. But that's it. I'm done. Thank you guys very, very much. And I will leave you with this.
I think it's great that Microsoft's kind of turning into one of the good